So, hello everyone. Welcome to episode 28 of our Warsaw.AI meetup. My name is Paweł. I will be the moderator of the session today. And it's the second Warsaw.AI meetup in Samsung. Did any of you attend the first one? Okay, a few people. Do you remember when exactly it was? I can tell you it was December 2019, even before the pandemic crisis. So we are happy to be back here. The meetup is organized formally by Quantum AI Foundation, Fundacja Quantum AI, that I co-founded and I'm still leading. We thank our partners and sponsors for supporting us. So first of all, we thank Samsung, of course, for hosting us today, but we also thank DataArt and No Magic AI. We invite you to subscribe to our weekly newsletter, Warsaw.AI News, if you would like to stay up to date. This is the agenda. So there will be a welcome speech from our host, Miss Agata from Samsung. Then Marcin, also representative of Samsung R&D Poland, will tell about AI on production, what's the catch. Later, Filip Szatkowski, Warsaw University of Technology and Ideas and CBR, will tell about adaptive and efficient computation in deep neural networks. And finally, Kwapisz from Omniviser and University of Warsaw will tell about hexDAG, new open source agentic framework. And we hope that you will stay with us for the after party and networking. The food is already here, so enjoy. Before we proceed, I also wanted to tell you about two other initiatives that are, let's say, branded by Warsaw.AI and organized by Fundacja Quantum AI. Just a bit more than 1 week ago, on October 14th, we started the second edition of our contest for the best diploma thesis in AI. So in Polish it's konkurs na najlepsze w Polsce prace dyplomowe w obszarze sztucznej inteligencji. Students or graduates from universities in Poland can submit their thesis by November 14th. And we are now in the process of organizing our first Warsaw.AI hackathon. Most likely we'll do it on November 29 and 30. It will be our first on-site hackathon organized within Warsaw.AI. Okay, without further ado, I would like to invite a representative of our host to also welcome you and tell more about Samsung.
Thank you very much. Hello all. My name is Agata Różycka. I'm from Samsung. Before I start, I have to tell you a little anecdote. I was 100% sure that today's presentation is in Polish, so sorry, I will be improvising a little bit. I'm very happy to welcome you in SRPol here in Spire. We are Samsung R&D Institute Poland, and I'm very glad to welcome all of you here. Samsung R&D Institute Poland, I saw only a few hands raising before asking about last event organized by Samsung. So most of you may not know that Samsung has R&D in Poland. And my main goal today is to make you realize that and understand that we are here and we are doing very cool stuff. So that's my idea, and I will tell you a little bit about our team and what we are working on, and then I will give my voice to our prelegents later. So what we are working on, we are one of the global R&Ds. Samsung has a network of those, and the Polish one, after Asia, is the biggest one. So we are very big, so we have to work on many different things. So of course we are working on AI, for that reason all of you are here. We are working also on device innovation, communication media, and of course a lot of different platforms. For example, Tizen. You may know about Tizen platform. So there are a lot of projects, a lot of groups, and a lot of people working together here at Samsung. And what we are doing? We are working on the language intelligence. So the team that I'm leading, it's called Language Intelligence, and we are working on natural language processing. Very hot topic right now. But we do not work with robots. This is just the idea that we would like to realize one day. Our work is a little bit more simple, and devices that we work with are a little bit more simple. So, for example, we are working with TVs, we are working with fridge, and with mobile devices. Our goal is to commercialize the language-related solutions for Samsung ecosystem devices and help users to use those solutions in everyday activities. So we've been working on Galaxy.AI, you may have heard about it. It was quite a hot topic last year with the new Samsung S25 and S24. We work also on Bixby. Bixby is the voice assistant of Samsung. It's a little bit like Siri. I don't like this comparison, but Siri is more popular, so Bixby is something like that. And for example, Vision AI Companion, this is a new thing related to the Samsung TVs. How we work on that and what is our main focus at work? Of course, it's innovation. We are not only D, we are also R. So we are also research institutes. So we try to work on very new applications for our devices and to do the research for the products that we currently develop. We are also user-centric. So we have to think about the users because we are working on the commercial solutions. So we want those solutions to be reliable, to be applicable, and to be useful to all people using Samsung devices. And the last thing is cooperation. Our team is quite unique because we work with engineers, linguists, testers, development teams, DevOps, release managers. There are a lot of different people that have to work together in order to commercialize the new solutions. So you can imagine the hassle is quite big. But working internally and co-working internally, it's not only a way of working with Samsung. Samsung also works with external companies, with universities, and for example, some startups. And for that reason, we are all here today, because we want to inspire, we want to understand your ideas, and we want to show you that we are here and we are developing very nice global technologies. And to inspire you a little bit more, I will give voice to one of my amazing leaders, Marcin Walas, who is already now, yes. Marcin is going to talk about how it is to implement AI on the production. Thank you very much, and please remember, we are here. Marcin.
Dziękuję, żeby nie było, że nie ma po polsku. Thank you. Thank you for this nice introduction. To be honest, I'm a little bit stressed. I had 2 months holidays, because of how many reasons, so I'm really stressed, so sorry about that, but still that's mine. So I wanted to invite you for this story, which is very connected to what we do here at Samsung R&D. And I really like this set of the presentations today, because they are from the 3 different worlds, like Filip. I don't know where Filip is. Filip will show us some research-oriented things. Jan will present the agentic framework, right? Very nice. And I will tell you something about the production, which is already there. So, so sorry about that, but probably not the same scale, right? So anyway, a little bit different. Oh, and you never know. Oh, I wish you Galaxy AI audience. So the first thing I wanted to tell you was actually why I'm here. Sorry, I said I'm stressed. So imagine this 20 minutes talk as a kind of meeting in the tavern. We meet together, maybe after the talk, drinking water or drinking whatever you like, and sharing some ideas with the experience. And I will give you some 3 stories, which are somehow related to what we did here, without answers, unfortunately, with only the questions, because I think these are open problems. So imagine when I would be talking, imagine that after the talk you probably will have different thoughts. Probably maybe some of the things will be controversial to you. I think I would tell at least one heresy today about AI. So I hope this you will enjoy it, and it will inspire you to look on the AI AI research, AI commercialization in a slightly different, a slightly different way. Yeah, so what's our story? Agata said that. Unfortunately, when I prepared the slide, I didn't know that Agata would tell you about it before, so I will skip this. Yeah, so the question is why I'm here. So what inspired me to actually invite you for this talk is this, you know, I think it's not only about AI, it's actually about software engineering in general. Like, so when you have this great idea about, I don't know, LLMs, machine learning or whatever, you think that your project will go like this straight line. And I think in every year we have a you know, golden solution to all of the questions. Like, I think this year agentic architectures are the solution to all the problems which humans have, which is probably not true, but for sure they solve many problems. Last year the LLMs were solving all of the problems, yeah, and before that transformer, and before that deep learning, and so on and so on. I'm so old that I remember the times where we had support vector machines which solved all of the questions, right? That's a long time ago. So, and I feel like after several projects we commercialized here in Samsung R&D and before my work at Samsung, I feel that the reality is much more complex. One of the reviewers of these slides asked me why you are traveling back in time, right? And sometimes I really feel that we need to travel back in time when we do the AI project, because we know, we need to get back to the initial assumption and redefine them, maybe change the model, change the architecture, because the reality is different than we expected. So this is the inspiration for this talk. Like, the reality is there, it happens, and if we touch the production, when we touch millions of users, which is our case, it touches us a lot. So my stories are very simple, so and obvious one. Like, the first one will be touching the problem of benchmarking on evaluating the models, something which we see in every scientific paper about AI, machine learning. Like, in the end, you always have, this evaluation sheet. The second one will be about the QA. So you think that, okay, everything is done, and now someone needs to check, does it have the high quality? Yeah, and what specific problems happens if you try to do it like with the AI in the back? And the third one is, okay, everything is tested, people used it a lot, but someone has found something is wrong with it, and now I need to fix it. And why it's different than the traditional software. There were some bonus stories which I not tell you because I'm a talkative person and we will not have time for that, but we can talk about them in the after talk. And all of the stories are actually a trap. I like this. I don't know if you are Star Wars fans. I really like this part of the Star Wars trilogy when Admiral Akbar says it's a trap. Because like, treat these stories that there is a catch in every of these statements, and I will try to at least explain what's the catch from our perspective. So let's start with that, okay, I have this, okay, let's call it machine learning model, and it receives 99% or 99 F1 score or whatever. Like, this is the asterisk, like, imagine that it's a really high number, right? So, and I ask myself, can I go on production? But when you dig deeper, so what's the catch behind that for us? Oh, what's the catch with these things? That you look carefully, and it seems that, for example, for the ASR, so the speech recognition software, it may be that, okay, this missing 1% is the only one single word. But the problem is this word is something like yes. And you can imagine that, okay, this is something not too good because it's a quite common word in English and probably in all the languages, right? So you can also think, okay, that all of my voice assistant features like Bixby, they are working okay. Like the classification works perfectly. Like, it understands everything, but for some reason it never is able to set a timer. And I picked this function on purpose because that's the most useful function for me, because I never know how to do it manually without the assistant. And the third one is maybe not so obvious, and also happened in our case, that okay, for example, the translation software which we are doing, it's okay, but for some reason it uses some vulgar words, vulgar language, but in the context of popular songs for children. So you probably, like all of you who are working on AI, you probably know those problems from the scientific papers. Like the third one might be like something about the AI ethics, right? And the catch is how to cope with that, how to cope with this pilot, and how we do it. So let's get to the tavern, and I will talk about 4 things we try, or we do in Samsung at our team. And the main thing is that we need, like, even if we reach the high score, it doesn't mean that we shouldn't check the remaining 1%, and think of it as a kind of from the business perspective. And sorry about this slide, but I wanted to start with that because all of this is, when you do something on the production, all of this is about asking yourself what is the added value behind that. It's not about the numbers. It's about what it will bring to your company, what will bring you to management, which might have different goals than the company. And especially this is why I put it in red. What's the value for your users? And this is something I would like to take a little bit deeper, because you can think of it, of the question about importance and the value for the users, about redefining your test set, evaluation sets for the machine learning based or AI-based software. So something which we do here at our teams is like actually defining the business value in the language of test sets. As you can see, this is of course artificial example. Many things might be considered here, right? For example, if you're doing something related to the language, you can think about, okay, covering the language in general, like the specific grammar things, like the vocabulary and so on. In the context of the products we have, like TV and mobile, maybe you will more care about specific, areas of the language. So, for example, sports, for some reason, might be more interesting to you than all other things, right? You might think about some kind of context or localization of your products, so region-specific things, dialects, and so on. There's, for example, cultural differences between Switzerland, French, Canada, even if they use the language which has the same name, which is French. It's still like a different language, like French in Switzerland, French in France, and French in Canada. And actually, even in France, French in northern regions are different like in southern. So this is something about a story about the splitting the test set in a more product-oriented way, and defining it in a usual way in that strategy, and what you can do then with that, if you know that some business cases are important to you, instead of telling, like for example, F1 score increased by one point, maybe it's better in the production to say something like common phrases are now back to green, because it actually means something, right? But what does it mean that F score is at some point? I remember, and this is not Samsung story, but I remember my first production system, which was a machine translation, I think more than 15 years ago. I actually was, at that time, BLEU and Meteor were the metrics, the most common metrics for machine translation. And I discussed with leader of the company I worked, but actually also my professor, why you are not caring about BLEU too much, because, and he explained me, because the persons who pay us actually care that the numbers, the currencies will be translated correctly, because this is like this is the most important thing for them for the translation. So imagine that, like, this was a very specific company, right? So after that, we actually redesigned some of the metrics and like had some kind of indicator lamps. I must say it, I call it after my colleague from that company, Mrugenlampken, and I cannot translate it. It's a kind of German thing. And this is approach I would like you to invite, like to think about when you think about the production, right? To think about, not about the numbers, but about such indicator lamps for all of the things you will define in this business analysis. And last but not least, like there's always a story about logs. You know, you are now AI-oriented persons. You know, data is the crucial thing, right? Without data, there is no AI, right? And the best source, maybe not best, but one of the, I believe, one of the best sources for the data for AI is usage logs, of course, if they are available. And this is like the obvious thing, but I still wanted to put it here because in the products we are creating here and in our team, it's actually a very important process. I think probably the most important, like to after the release to release always have this, you know, observation phase to check what's happening, to have the observability of the logs, to have the ability to collect them, to digest them because it's not always obvious, to sample them correctly because in case of the language you probably are aware of the zip flow, right? So the sentences, the similar sentences may be expressed in a different way. So it's also a matter of sampling it correctly, analyzing and have this, you know, feedback loop about improvement of the model and never-ending story about the improvement. Yeah, a short story about so that was the short story about the first catch I had actually in the beginning of my work, not only at Samsung, but before Samsung. So it's not only about the numbers. Like when you come to production, it's actually what matters the most. It's like in this Pareto rule. The missing 1%, it's what matters the most. This is something you, in spite of the high number, you still need to take care of it and actually check what kind of business value are you missing because it's not handled in the model. So that was the first story. Yeah, maybe I will give you a pause. Oh, myself a pause, yeah. Okay, a question to you. So the question, who has this experience about, you know, you created a model and delivered it to any kind of QA lab or asked someone to test it? Oh, I know this guy, yeah. Yeah, Jan. Yeah, because you would, yeah. So some people do. I know we have people from our MQA lab, so they are doing that. And Marcin, this is the story. This is part of this presentation. You can blame me, and you know, if I'm telling too much, just raise your hand and say, yeah. So of course, once again, this is a kind of software engineering, never-ending software engineering story, right? Because in the traditional software, sorry, I have never created anything in the like non-AI software, so maybe I'm mistaken. But from what I know from my colleagues, like there's a never-ending fight between development and QA, right? Because some develop software and some test it and try to prove that it's not working well, right? And I think that the AI, it's like to somehow boost this problem a lot because you know that AI models or machine learning models are a little bit more complex, let's call it that way. So for example, it may happen that, okay, someone starts testing that and after a minute it has given completely different result. So you can like imagine that it's probably about this, like, you know, the AI is not deterministic, right? There are probabilistic models in most cases. The second thing, okay, someone will ask you, okay, but what are the details about the pass, right? In the traditional software, you have the passing criteria, you have the like everything well documented, at least in the good projects. And in AI, it's not so obvious, right? Because what does it mean that the sentence is translated, right? Like professional translators will not answer this question, and they will actually probably discuss a lot about the good translations. The third thing is, okay, maybe you have given something to retesting, but you know, you change only a part of the model. Like, for example, you trained a part of it because you needed to fix one function. So why you are asking us to retest everything? And you, from like everyone who had any experience with AI, of course, will understand that, you know, if you retrain the model, you have no actually there is no guarantee that something different will not break because you have fixed something, right? And the second last, it might happen that, okay, a person, let's call him Mr. T, for speech recognition, for example, one person passed it, and the second person, who was female, didn't accept the result. So you may probably wonder, yeah, it's probably about the different requirements for the test, because female voices and male are different. And the last but not least, very recent problem, especially with the LLMs, someone was offended by your system, and it happens, yeah, even in our case. So all of these stories actually something I would like you to invite you, if you go to the production, that to look on it on a different way and stop this war. Like, this is my statement. Stop the war between testers and developers, whatever it's AI or not. And let's get back to our tavern, and I will tell you the first very basic thing, and I think it's very often omitted. It's simply, you cannot test something you don't understand. So if you want someone to check your model, let them learn it first. One year, I think it was 2 years ago, I was amazed because we organized here I don't know, Marcin, if you were with us at that time, we organized here the special workshop for all of the testers around Europe. You know, we are doing software for various European languages. We have gathered them here in this building, let them work together for a week with our machine learning engineers, speech recognition expert, and they explained what's the basics of the system, what's the architecture, why the result is unstable, why it behaves like that, and after that the magic happened. Right? They understood what were the problems with all of that, and it's like that simple. That if you want something from the testers, like, first let them know about your system. And this is something very important to me, and actually this is important. Because I feel that in many cases, and I hope, Marcin, you will agree, that the QA labs should be always considered as a part of the machine learning team. It's not separate. It's also like, you know, if you're doing research, you split train and test set, but you don't split people doing that, right? You don't split processes much. You don't write one paper about training and another one with the evaluation, right? It's there together, and the same is on production. So QA is a part of the ML team with all of the consequences, and because of the AI stability, all the problems we know about AI, about ethics, about hallucination, about all the different things which don't happen in software engineering, traditional non-AI software engineering, you need to give them more freedom. Because now they need to explore the model. They need to experiment with that. This will require from them to have more time for it. It will cost more because AI is more complex. And of course, you need to even sometimes ask them about provoking your model. And probably you know this concept of red teaming, you know, with these hackers of the models who intentionally try to do something wrong with the model. So this is something I would like you to listen to. But the last thing is something I also feel is kind of important, because on many conferences, like you have some kind of philosophical talks about ethics. I love AI ethics, by the way, about regulations, about hallucinations. Sometimes, there is someone asked me about compliance at Samsung. Yes, so we have compliance on the slide. So this is actually approach I would like to take. I take here, that every such philosophical question or concept stops like it's not philosophical after you define it with the testing with a specific test. So this is something I would like you to think about. If you're thinking about, I don't know, regulations like AI Act, about AI ethics, about hallucination, maybe QA Lab is a good target for coping with that understanding, of course, assuming if you treat them like in a slightly different way. And like, what's the conclusion? I'm not sure it's a good metaphor, but yeah, I will follow it because I've made up. Actually, yeah, LLM made it. Sorry, this is not mine. So, yeah, if someone thinks that testing software is an art because it's a kind of creative activity, so I think like the software engineering, like software testing without AI is like realism in painting. So you know, I think all of us know what's on the picture, right, on the left. Then when it comes to AI, it's on a different level of abstraction. It's more about Picasso rather than Helmoński. So you need a little bit more knowledge. You need to, you know, you need to look on it for a while. Actually, I didn't know that it's free musicians. I figured out after I read the Wikipedia Commons title. But I think that's the difference, like between testing and probably also doing the AI. So having this in mind, if you ever want to test something, if you will be testing something with your AI model, please remember that, and I hope you will cope with it better than me initially, actually. So this is the second story. And the third one. And the third one, I think there will be heresy here. So, yeah. Okay, we are after QA. We know that, okay, the model is perfect because now it's 100%. But for some reason, there is a bug. And like digression, I really don't know why people don't like bugs. Like, this is the picture I took a couple of weeks ago. It's beautiful, right? So why we hate them? I really don't know. So what's the catch when it comes to AI? The catch is that, for example, your model training takes a week, right? And that's a problem because the bug is there and users are using it, and it's what to do. You go to your ML team and they say, okay, we can retrain the model, but we cannot guarantee the training will fix it. So we may have another training needed, right? So it will be 2 weeks or maybe another one. Yeah, and the third one is about explainability, you know, AI explainability, because maybe it seems that we are not sure what actually is the source of the defect, like why the model hallucinates, right? And the fourth one is especially important when when multilingual models appeared, or maybe not appeared, but started to be more popular. That, okay, fixing it in English breaks something in French, right? And of course, the last one is extremely important. In the corporate world, it's simply costly. So let's get back to our tavern. I'm going to the end. Sorry, I said I'm a talkative person. Sorry. So I'm going to the end. Like, I would try to be quick. Like, if you have these problems, if you picture them before they happen, you can prepare for them. And the heresy, I think, is that actually I don't like end-to-end architectures too much because they are very nice, but when it comes to problems like that, they are difficult to actually cope with. So something which a kind of thing I like, maybe not like, is to get back to the past, and this is get back to the past and think about other maybe less complex models, or even not models but approaches, which will be a place for quick fix. So it could be a random forest classifier, for example. Yeah, it exists and they are still quite useful. maybe it could be a grammar. Yeah, I'm very old, so I did natural language processing where grammar were still quite popular. Maybe it could be I don't know, word to vec embedding or BERT-based classify. Yeah, the one thing is that think about what could be the place for a quick fix for your model. But actually the catch is that actually you shouldn't use it or overuse it because you can abuse it very easily, right? It can grow a lot and it's not, the complex model should be the first target thing. So the approach I promote in our team is actually to do it in parallel, right? To have this quick fix place, but in the parallel, like, do it by the book, and after you confirm it's fixed, revert it. But yeah. And before, the second thing is when you is this concept that before AI, when we are fixing anything in the software, we were fixing in the source code. Now, I think we are mostly fixing this in data. So it means that you will invest a lot of time and a lot of your development time for covering like data cleaning, for data verification, and so on. And this is something we, like a piece of advice, and I hope we will talk about it later on, that every bug should be inspiration. Maybe not every, but every, like some of the bugs might be an inspiration for the new tool to explore your data, to check it, to have a guard in the data or cleaner, automatic cleaner, which will make it better, better, and better. For example, when it appeared that, maybe I will stop myself here. And the last thing is, like, you simply need to be prepared. So before you go on the production, before actually you design, during your design of the system, think what kind of reactions you will need to take when a bug appears. Because maybe 1 week with the bug is okay for you and for your sponsors. In some cases it's okay, right? But in many cases they aren't. In many cases you will need reactions like in minutes. So in that case you need to prepare a plan for that. You need to place in the architecture to do that. And this is something I would like you to think about, because to me a fixable system is much better than the flawless demo. And this is the last conclusion I would like you to leave you with. And last slide, I will promise it's the last one. Yeah. The last slide, it was actually this. I know it's a very old paper. It's for 2015, so it's like prehistoric times. But I think it's still valid. I think I shown it several times on different talks, and you know that. Okay, like the essence of machine learning or AI is always in the center, right? Like this, here's the architecture of your LLM, or I don't know, the everything behind that. But when you go into production, everything which is around it is actually takes most of your time. Like, and this is something I would like you to leave you with, because it's still the story which is very inspirational. That's not a good word. Or maybe other way around. You know, in the end, you see your system which is working with the millions of users, right? And after all of this, you know, struggles with the QA, with the bugs, with fixing it, with figuring out how to retrain it and how to make it working. In the end, there are these users who are using your system, and this is something which, like, actually gives some energy to do all of these things, even if they are sometimes very difficult and sometimes actually contradictory to each other. My name is Marcin. I hope you want to talk with me later on, and please talk also with our colleagues who are here. And yeah, Marcin, do you like me still, or you left? Okay, so I lost colleague. Yeah, sorry. Yeah, anyway, thank you very much. Maybe some questions.
Yes.
Please
same.
ask one question because my boss said that there's a KPI for questions. So please, one question at least. Bartosz, you're supposed to ask one question. Where he is?
Why is there a KPI for questions?
I made that myself. So that's my personal KPI.
Okay. Would any of you like to ask a question to Marcin? Yes, there's one. Okay.
What did I mean by logs? Usage logs.
Logs from when a user says something to the
For
computer
example.
and it's scripted, right?
And when I said logs, I mean the usage logs, and that's actually a great question. There's a big story about that because by usage logs I mean, for example, if you say something to Bixby, like in many cases we are able to collect such logs. Of course, there's a big, I will not tell you about, about GDPR and something like that, about privacy, because I'm not a lawyer, so sorry about that. But when the lawyers will explain that, you have the usage logs, and this is the best source of the data, and this is something I referred to. And for every system of that kind, we are doing some kind of logs are available. In some cases, because some of the services we are doing are on device, so we don't have logs for them. But you can still collect them using some kind of, we call it user trials. It's a kind of usability test where when you have some of the persons who take the devices and they know that they are, being collected, and we then upload them from the devices. But this is something actually sometimes which is omitted. If you are, but I hope not these days, but like in the past it was. Always when you go on the production, think, can you collect the logs? Because this is the best source of the data, right? And you shouldn't lose the data. Data is gold. Oh, the price of the gold dropped, I think so, but it's still very expensive. Yeah. Yeah. Thank you for the question.
Okay, thank you. Do we have more questions?
So you mentioned that contrary to conventional systems where you can roll back very quickly and just fix a bug and deploy it in minutes, in here you need to retrain. It can take, for example, 1 week. So what are, and you mentioned that you need to be able to say, react to these bugs, even though it takes a lot of time to say fix them completely. So what are your tools of trade to say rescue such systems?
Oh, a tough one. Cornel! Maybe you'll answer this question. Yeah, it will be difficult to explain actually without going into details of the system, particular systems. So, because also there's also another thing which I don't want to explain, that there is always a release cycle, right? So for example, for Galaxy, I know the updates are weekly or bi-weekly or something like that. So anyway, there is only a fixed point on time where you can actually have a fix. It's very rare that you can do it in minutes, right? At least in the projects I participate in. Still, it doesn't mean that we can only count on the retraining the model because of the different other problems I have mentioned. For example, we don't always can guarantee that that the model will actually converge to the solution which will have a fix. So yeah, in reality, what we do is actually have some kind of, I call it, they will blame it for that, because I call it a duct tape component, and that's my name. Sorry, quick fix. I think quick fix with the smaller model, like I think I can give this. For the machine translation, it might be, for example, translation memory. Yeah. I'm a machine translation oriented guy, so I know more about it. So sorry about the particular examples from that. But I don't know if you know what's translation memory. Translation memory for the machine translation system is simply like the hash map of the good translation and source language and good translation. So it's like the, a list for hotfixing, like the concept very very long known. Yeah. So in reality, we look for the components like that, but they are very minimal, like only for the emergency situation actually. Yeah. So I'm not sure if I answered your question correctly. Don't worry, don't worry. Okay, thank you.
Okay. All right.
But this was a tough one, so.
Thank you, Marcin, and thanks for asking the questions. We are significantly behind the schedule, so I will now invite our second speaker, but let's thank once again Marcin for the presentation and answering all the questions. Okay, and now it's time for our second speaker, Filip Szatkowski.
Okay, thanks. So my name is Filip, and I'm a PhD student at Warsaw University of Technology. So over the course of my PhD, I have worked on adaptive and efficient computation, and this will be the topic of my talk today. And I have done collaborations with many institutions listed here, but my journey in AI actually started here at Samsung in 2019, so it's kind of back to the roots for me. So thanks for inviting me. But without further overdue, let's start with the outline of the talk. So I will try to introduce you to adaptive computation techniques in deep neural networks, and then talk about my research on early exit models and activation sparsity. So this is quite dense, I think, talk. I will try to fit within the timeline, but I have a lot of slides and a lot of text there, I think. So let's focus on images, please. There's too much text. So let's start with why do we need adaptive computation in deep neural networks. And there are two main reasons for me. So we are dealing with data that's very different in informational content most of the time. And we are not processing this data efficiently. What I mean by that is that if you look at these images, some of them are pretty obvious to understand. Some of them require more thinking for you to understand. And neural networks don't really have this property. I guess with reasoning systems we are trying. But most classic neural networks basically spend the same computations, dense matrix multiplications on everything. And this, I would argue, is not efficient. And this also kind of restricts our networks and their expressive power. So let me explain a bit more why I think it's the case. So first, we have many cases that show that networks that we use are actually too large and not efficient. One of these cases would be like lottery ticket hypothesis, which says that we have sparse small subnetworks that can be trained to full network accuracy within most models. The other case would be like knowledge distillation. Both of this basically mean that we can recover the accuracy of large network with a very small network. And the case that we need the large network for is basically that it's easier to optimize. We cannot optimize efficient neural networks yet. By the way, is it too close or is it okay? The other thing that I wanted to mention is that we have knowledge representation in neural networks, and in most of the models, if we do this analysis of where the knowledge actually appears, it turns out that most of the representations in early layers actually encode the tasks that we want to do very well. And here is the analysis of like input safety assessment. So how safe is the prompt with several LLMs that we have right now that are popular. And it turns out that 70% F1 score is reached by first layer already. So what does it mean? That more or less 30 layers in our network are not really needed for most of the cases that we work on. And this is reflected by the way that dense neural networks actually operate if we look in depth in what happens there. So these figures are from T5 model. This is a dense transformer from 2019, I think. And the paper here investigated post-ReLU activations in these models. And they point out that if we look at these activations, then post-ReLU vectors are mostly zeros. So only like 10% of the activations is non-zero in these models. But we still do dense matrix multiplication, which is huge computational waste. So, as I mentioned, we already have adaptations of adaptive computation in a way of reasoning models. We also have MOEs, but I would say it's still not yet in a place where I would like it to be. So, with that, I will introduce you to some adaptive computation techniques that we have right now in neural networks. So, we can think about adaptive computation in standard models on three, let's say, axes. One of this would be sequence or input axis, where we want to design algorithms that either drop tokens or drop parts of the KV cache, depending on the input data between layers. And in this way, we reduce the cost spent on processing tokens and reduce the cost of attention in case of transformers. We also have depth-wise adaptability, where the model decides how many layers to use per data point. Or sometimes we have like one layer that's called recursively. And we also have like width-wise algorithms where each layer decides how much computation to allocate on a sample. So, as I mentioned, we can think about reasoning models or like multi-agent systems as adaptive computation, but I would say this is out of the stock because I haven't worked on that. I'm sorry. There is a lot of methods in this class of adaptive computation, and I will focus on early exits and activation sparsity, as this is what I've done over the course of my PhD. So let's start with early exit models. And the idea behind these models is quite simple. So let's think about classification task, where standard model here would be built of convolutional layers and a final classifier. And with early exits, we simply attach additional heads to the intermediate layers in the model. And we have some, in general, exit rule that decides whether or not the prediction or output of the intermediate classifiers satisfies that. So in most cases, it's basically if the intermediate classifier is confident in the prediction, we return the prediction. But we can think about many different criteria. And what we get with this kind of models is usually the ability to adapt the computation based on this like confidence criterion or exit criterion. And we achieve this kind of computation versus performance curves, where as we relax the exit rule, we spend less computation because we exit at early classifiers, but our accuracy drops because obviously early classifiers are worse. Otherwise, we would just use the early classifier for everything if it was not worse. So most of the research on this kind of networks cares about improving the cost accuracy trade-offs or cost performance trade-offs. Cost here is measured by flops, so how many computation we do on average over the test data set. And what we want to do in most cases is to move like the knee point where the performance starts to drop as far to the left as possible. So there are many ways to do this, many angles that researchers try to work on this. We can think about like training algorithms for these multi-classifier networks. We can think about like how to design exit rules, design more efficient architectures. So this is the example of the paper that I worked on in 2023 with the Agata University. And here we improve the classifiers in early exit networks by attaching cascading connections between classifiers and assembling heads. So each subsequent classifier basically has access to all computation from previous classifiers. And it improves the cost accuracy trade-off, as was shown on previous slide. At least it was the best algorithm in 2023. It's probably not anymore. Okay, but what I wanted to talk about now is the more recent work on early exits that we submitted to one of the New Reefs workshops and will present in December. So in these early exit networks, one of the most researched things is calibration. So basically, calibration refers to a degree to which model's confidence reflects its actual accuracy. And since most of the early exit networks use prediction confidence to exit, most of the research works on early exits kind of touches on calibration or focuses on calibration, which seems quite intuitive, but we actually made a simple observation that it might not be all that we care about in this kind of networks, all that we need. So basically, in these networks, we have the cost accuracy trade-off, as mentioned. And no network is perfect, right? So some samples in the network will never be classified, even if we process it through all the will never be classified correctly, even if we process it through all the network, right? So for these samples, the optimal decision from the computational point of view is actually to exit as early as possible. But if we strive for perfect calibration, in case of the samples that are wrong, our classifiers will actually try to assign like random probability, and we never exit. So we devised this kind of early exit failure prediction score, which is pretty simple. Don't read text, as I said. The idea here is we have the yi, which is output of the classifier, at some part of the network, and we assign 1 to the output of the classifier if the output is correct, or if all subsequent classifiers are incorrect. Right? Pretty simple, what we care about. And what we found out is that actually if we examine calibration in more detail, we will have this case where we can make the network overconfident or underconfident. This does not really reflect that much in the cost accuracy curves here. And actually, it's probably not very visible here, but you have to trust me that the blue curve is a little bit better than the black curve. So we have the overconfident network performing better than perfectly calibrated one. Why? Because, as I mentioned, we have the samples that sometimes we want to get rid of early. But if we measure the calibration error, which is the middle plot, we see that expected calibration error for each head in the neural network will be way higher for the overconfident model. And as I mentioned, a lot of works use calibration for like a measure of quality of these models. But this does not reflect what we want to optimize for, actually. But and if you look at the score that we propose on the right, this actually reflects the quality of the model that we have. So this is kind of work in progress still, but I think it's pretty cool. It's pretty simple observation, and right now we are working on including this notion of efficiency in the design of the networks itself to not only provide like a better metric, but also use it to improve the model quality. So let me now mention the other work on early exits that I have published at ICML. So this is a different angle. This is the application of kind of early exit networks in continual learning. I don't want to go too much into continual learning here. Basically, we have the learning setup where we try to train the model on sequential data sets, and we basically care about knowledge accumulation without forgetting. So I mentioned auxiliary classifiers in the title. It's more or less early exit network, as presented here. And we had this hypothesis that the adaptive networks should be more expressive in this continual scenario. So we evaluated continual learning models and methods with the early exits and without early exits. And basically, I won't go into detail here. What happens is that simple addition of early exits makes the models better overall everywhere. And we have this cool property that with early exits we have also the ability to reduce the computation based on the confidence thresholds. And nice part of this in context of continual learning methods is that we have the curve flattening out at like 80% or 90% of the computation that we would use with the standard network. So it's kind of free lunch in this case. We get increased accuracy because of the expressivity of the model. And we can also reduce computation if we tune the threshold well without the performance overhead. So this paper is a nice case for me of like added expressivity from this kind of networks. And right now I wanted to mention the other area of research that I work on, so activation sparsity. Early exit networks are kind of depth-wise adaptive models, and activation sparsity refers to width-wise adaptivity. So to help you understand the concept a bit better, we have this mixture of experts, and I think most of the people here are now familiar with this kind of architecture. So with mixture of experts, instead of like standard dense feed-forward module, we have many feed-forward modules that are sometimes smaller, and we have a router that would select like k of this per token to process our information. And MOE is usually used to like efficiently scale up huge networks, but it can also be used to achieve efficiency and accelerate the inference in trained models. So as I mentioned already, we have this activation sparsity phenomenon where most of the activations is very small or zero. So we can group the neurons that fire together into experts and basically train routers on some kind of high-load data to achieve very fine-grained MOE. And if our router is reasonably good, then this allows us to perform the computation with 25% or 55% of the or 50% of the original neurons without the accuracy loss. So that was pretty cool, but we also managed to improve on it with our new paper from last year. So the idea here is also to use this dense to MOE conversion. But we first wanted to examine actually like the activation sparsity impact of this conversion. So we trained several models with different sparsity ratios in the activations. And we saw quite predictably that the loss of the model post-conversion goes down if we use the models with higher sparsity as our base pre-conversion. And here we achieve the same kind of like compute versus performance graphs. But here it's loss, not accuracy, because it's language modeling on, I think, GPT-2. And we get the dynamic characteristic by using different number of experts. So like it's 32 experts or 64 or something like that per dot. So this is nice, but we also noticed something that was a bit worrying for us, or maybe an opportunity for us. So basically, we have seen a huge variance in how many activations are actually used per token. So this prompted us to introduce this dynamic gating idea. Basically, we will have samples that are easy, that will require few experts to process, and we will have samples that are harder and will require all the experts, as here with some random images generated by, I think, some diffusion model. So how do we achieve it? We trained our routers on some held-out dataset to predict the norm of each expert. And if we have the information of about the norms of the experts, then we can use several heuristics to decide on how many experts do we want to use. And what we ended up using in practice is that we take the experts with the highest predicted norm and also activate all the experts that are above some threshold of this maximal norm. And in this way, we also get these curves of spent compute versus model accuracy. And we basically see that across the models that we tested, so encoder models for classification on the left and GPT Gemma with language modeling on the right, we get pretty nice improved trade-off curves. But I think the coolest part of this paper was actually that we managed to transfer the reduced computation into actual latency. So it's non-trivial to actually transfer this dynamic algorithms, transfer the gains from the dynamic algorithms to latency end-to-end. And the left curve here shows that a naive PyTorch implementation actually is very inefficient, and even if we spend like less theoretical computation, we end up spending more time on processing. But our kernel managed to more or less scale the time linearly with the number of used experts, so flops, to the from 0 to the cost of original MLP. And end to end, it kind of transfers to somewhat 30% latency improvement on the VAT model before the quality degrades, because we only worked on feed-forward parts of the model. This is the final slide about this paper, and it kind of encompasses the idea behind adaptive computation quite well, so I wanted to include it. So this shows per token spent computation for several images. And we have this nice property that we strive for, where the parts of the image that are like semantically important for us are using more computation. At least, like, well, it's very noisy, but you can see the patterns. Finally, maybe I'll just mention one final thing, one final avenue in that. So we can take the activation sparsity a bit further, and we can get rid of the routers. We can treat single neurons in the model as experts. And if we get rid of the router, just use some kind of heuristic to determine which neurons should we activate. For example, tune some kind of calibrated threshold. We can get even more efficient inference. So this is an example of how it's done in most of the papers right now. So dense layer inputs are sparsified based on some kind of threshold. And then we also only load the part of the weight matrix that corresponds to the part of the activation vector that we need to perform computation. And this saves some computation. But it's actually not so easy in transformer models right now, because most of the LLMs have this kind of free linear layers instead of two, and they don't use reloos as well. So we have way more lossy kind of pruning here if we prune the activations, because there are no zeros here. But this paper has one interesting plot here that I just want to mention before we finish. So there we looked at how much activations can we actually zero out before the performance drops. So we call this critical sparsity. So critical sparsity is the sparsity at which the performance degrades. We look up into activation vectors in all parts of the feed-forward networks in transformers, so intermediate activation, input activation, gate activation, and all of this across, I think it's 14 models or something like that, of different sizes. And we find that we can get this functional sparsity everywhere in MLPs, which is pretty cool, and I guess it bodes well for the research on this direction in the future. But yeah, this was still ongoing work as well. So let me conclude with very fast bullet points here. I hope I managed to convince you that this stuff is kind of interesting and can lead to more efficient networks. I also shown some cases where these networks are like more expressive and can improve their performance. And we see adaptation of these paradigms in some aspects in current ML, already with MOE's reasoning models. But there is still a lot of work to do here, because the cost accuracy curves are, well, trade-offs. So these methods always kind of provide lossy acceleration and are not so hardware friendly. But, well, those are challenges to overcome. And it's not so bad, because it means I have still work to do during my PhD. So thanks for listening. I hope I'm not too much over time.
Okay, thank you, Filip. It's time for questions. Do we have, yes?
So you're adding new tricks to this neural networks, but it all looks like when there was image recognition done in classical algorithms, that you were always adding new tricks, new ways of doing something, and you were improving in some measure, but eventually it was all replaced by neural networks because they were learning everything at once. So my question is, did you think about a bitter pilled version of your work? Like, what would be this direction?
Well, in a sense, if I understand correctly, you're asking if this stuff is overcomplicated, or if it's over-engineered, and I kind of agree a lot of this might be.
Okay, let me. It seems overcomplicated when we go into this, but my question is not about the complication of this in itself, but my question is about the bitter-pilled version of this, where we have a meta learner that learns how to adjust the network when presenting the training data. That, well, I don't know. Maybe it learns to adjust the network. Maybe there is a genetic algorithm that mixes two networks to get a new network that behaves better. But basically, it is about a system that improves this automatically instead of adding new tricks by humans.
Yeah, I mean, I don't really see what we do here with like adaptive architectures as like too much of post-training tricks. I think what we would have ideally is having architectures that are like implicitly adaptive and would learn this kind of adaptive behavior. I would say MOEs are kind of like this, but we still don't know how to like make MOEs specialize and like be efficient actually. Because we cannot train MOEs without balancing, and if you have balancing, you lose adaptability. But yeah, I mean, the way I see it, we are kind of moving towards the adaptive models more and more with MOEs, with the reasoning stuff. It's just that like it's hard, it's not hardware friendly, and yeah, I mean, I think it's slowly going there anyway. And I believe that like simpler stuff prevails over time. But if you think about it, actually, like MOEs or reasoning are kind of also simple ideas. It's just that like we don't really know, or we didn't know that well how to optimize them until very recently.
Okay, thank you. Another question.
Yeah, have you researched how retraining for a specific data set affects this area of research? Like, I'm curious about a scenario where I have a data set. I would want to have an efficient neural net for that specific data set, and this tool looks very promising for that scenario. Like, is there any research about it? Have you done anything research around those topics?
You mean how to adapt like a dense model into
or MOE models, but specifically you have the data set, and in that context, like you want to transfer some of that knowledge specific to this data set onto your model. Like you want it to be performant in the context of that data set that you're working on.
I mean, I think it's a very general question, and from my experience, it's actually like very different depending on the task that we are doing and on the model that we are using. Because with LLMs or like larger model in general, I think it's quite easy to actually like destroy the knowledge in these models if you try to do this kind of adaptive computation. So what people do actually is try to come up with like less invasive methods, if it makes sense. So parameter efficient fine-tuning or model merging is is like some kind of maybe a hack to avoid changing the model too much. And yeah, I mean, there is a lot of research on that. If you want to talk about this later, we can maybe go a bit more into detail into that.
Right. Do we have more questions to Filip? If not, then thanks Filip once again. Thanks. Okay. And Janek, it's your turn.
So first of all, thank you, Paweł, for having me here. Secondly, you cannot see anything because I have to click something. I guess I should have an agent to remind me about that. Works or not? No idea. Maybe I should have to click something here. Guys, I need tech support. You know, this is why you need first, third, and third line of support, right? Got it? Or okay, got it. All right, there you go. All right. Yeah. Okay, so you will see my Cloud code for now. So let's focus on me. So guys, basically, what I want to tell you is that how many of you have built agentic solutions? Okay, some of you. And so if we think about what really agents are, if we really think about it from, you know, I have a background as theoretical physicist, but I often like to think about myself as coming from big data background, so software engineering background. So if you think about what really agents are, they are some kind of application components built on an infrastructure that are LLMs, right? So basically, if you think about like what is when you build an application, like I don't know, you build a web portal for your friends to sign up for your calendar, right? Then your infrastructure is what? Like a Postgres database, like this stuff, right? And agentic AI is pretty much the same, but with LLMs. So they treat LLMs as well as obviously other stuff like databases, blah, 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 as infrastructure. However, when you look at the way currently, okay, so actually, and if you think about best software engineering practices, right? I hope at Samsung, I work at Samsung as well, so I remember you stick to nice development practice. This was actually my first place where I started working, I know, 2 years ago, or 2 or 3, I don't remember. No, it should be 3, something like that. But in any case, so if you think about best software engineering practices, what should happen is that your business logic of your specific application should be decoupled from the infrastructure that it supports. For example, if you build an application, right, it should be fairly easy to migrate that application from Postgres to, for example, MySQL, MSQL, etc., etc. That should be the theory, right? Obviously, sometimes it doesn't happen, but this is what we would like to have. And it turns out that with agentic AI, when you look at agentic AI frameworks, so something like what Django or Fast API is for web development, this is not the case. This doesn't work that way. It's heavily coupled with the LLM providers. It's heavily coupled with the way you run it. For example, we tried to, at Omniviser, this is my company, we tried to build at a very early stage. I know that we will have some real-time running a lot of agents, and I thought, okay, I want to have it distributed. I want to run this like I have a central agent and then different agents on different workers. Basically, if you look at the frameworks that people built for agentic AI, it just doesn't work that way. If you want to do this, okay, you can run LangChain on the main part. I'm not talking about LangChain, but that's an example everybody or some of you knows. You have to run it here, you have to run it there, and all of the connections in between you have to build yourself, right? So there's no distributed place. The other thing is LangChain found out, and so far the other frameworks, that it's very convenient to represent agents and their interactions as a graph, okay? Or as a pipeline, like a data pipeline. or as a graph. This is a long graph idea. However, if you take a look into that graphs, they are cyclic. And how do you tell, based on looking at the graph, what is actually happening in your system? Oh, you have some batch of agents talking to one another. But how do you say what were the messages sent on the graph already? It is not apparent, right? And finally, there is the famous question I asked to my NVIDIA colleague, because I'm an NVIDIA instructor as well. And I asked him, hey, do you know any method to get a prompt from LangChain? He said, hell no, I don't know how to do that. Okay, so this was the introduction. So I found out that the AI agentic frameworks that were built are built for MVP type of solutions. And I ran on production. And so I want to run an AI agentic framework for a customer. And for example, I have customers that have 1 gigabyte database. So I want to run it with Postgres, right? Then I have another client that has 1 petabyte. Then I want to run it on BigQuery, right? I want to run the data retrieval for that. I have clients that need a very specific version of LLM, for example. They need a reasoning models. However, not for every task. So I want to change models. For example, I want to start an agentic framework with a very simple, for example, GPT-5 Nano, because it's just cheap, or a very simple local model. It depends on the client, obviously. I'm talking about enterprise APIs, so don't worry about security. This is for the lawyers. So, and if that fails, I want to run it on a better model. If you want to run that with current AI agent frameworks, you have to build your agent twice, which is not what we like. This is why I decided, and my company, to step back for a moment and build our own AI agentic framework called hexDAG. hexDAG means hexagonal directed acyclic graph. Why is that? Okay, so let me do you a little demo of how this works. Okay, and there's one more rule, one thing that pisses me off when I build this kind of solutions, is that I want to design, because if you think about AI agents, if you build this kind of solutions, what do you actually build? You build some kind of agent-to-agent architecture. So you want to have a clear template of what you built. However, in all of the frameworks, you put that into the code, so you mix the business logic, the way the agents talk to one another, with if-else statements, when JSON is failed, with the facts that API has maxed out, or your model is not fast enough responding if that's on-premise model, etc., etc. And all of this stuff is mixed into your code. However, what you are building as a data scientist, for example, building agents, you're building an architecture. So I want to make it clear that you build an architecture and the rest should be handled by somebody else. In that case, it's my framework. Because I'm the main contributor here. However, this wouldn't be possible if not our work with the clients and if not the rest of the team that did heavy lifting in the meantime. So, okay, here we go. I have to go to the terminal now. Where's my terminal? All right, it's over here. All right, now it's the test whether I remember my terminal commands. ls. All right, let's do Python 3. All right, and here is actually one more catch, is that I don't know if you like, but one thing I hate the most when building AI agents is that I have to wait to check whether the path I intended is the same as the path I coded. So you have to wait until the LLM processes. You often wait 3 minutes. You are pissed because it doesn't work. it's the same as with big data. So I decided to add possibility of mocking answers of LLMs. This is a very cool feature, actually. I really like that, because then you can just check whether your architecture works, and then you can check whether that works actually with LLM as intended, much faster. But that's a small feature. And this is what we're going to use here in the demo. So we have a ticket. My enterprise application crashes during the report generation. It's critical for quarterly review. We have customer tier enterprise. We see the implementation. This is the LangChain one. I'm sorry, I'm not against LangChain. It just, it's most popular. Here's my implementation roughly here. Obviously there is a prompt template. Okay. All right. So now let's move further. Right. So this is how hexDAG runs. This is what LangChain takes. The lines of code is 110, 400. It's much faster in processing time. It's, for example, in the fact that it's parallel, etc. The parallel is just automatic. In all other frameworks, you have to design whether it is automatic or not. For example, Google has parallel agents and sequential agents. So you have to kind of choose, then you forget that you chose that, and you don't know. The schema validation, this is where all of the frameworks are pretty good. Error handling, well, you can use try except, or you can do the framework. The retries, it's pretty cool because you can just write max retries. You have the observability and parsing. Right, so this is an example, this is another example. So for example, we have an error. When GPT-4o fails, who handles the fallback? This is this is how you handle the fallback here. You just write that the fallback model is O3 mini. For example, you need a better model. Oh, you can see my terminal, right? Yeah, okay, I'm gonna make it bigger. And this is the fallback implementation in LangChain code. A lot of this, right? You have to write that. You have to hope that your budget allows that, etc., etc. So this was a very short demo, and now let me tell you how I built it. Sorry, it's in Polish. I had this. I have to translate it. So basically, how it's built. It's built on a very simple thing. Is that LLMs are meant to be working with as much as any software. But it's not deterministic software. But we have to build it as deterministic as possible. And the best AI is the if-else statement. This is the first part. The second part is that 80% of AI workflows doesn't need agents. But it needs a good orchestration of LLMs and deterministic code. But no agents. If you build an multi-agent solution, then think whether it's not just poor architecture and you want to take a shortcut. It's often that way. I can tell you, we did that. We started with 10 agents. Now in the main engine we have, I don't know, maybe there's one left. But all the other we just did in a different way. We understood the business logic much better. It's much faster, much more efficient, much better. But still, if you want, you can run it with agents. And finally, and the third thing is the YAML. We do most of the agentic design in YAML. It doesn't mean we don't have to code. It's not a no-code solution. It's a low-code solution. So we design the logic that how the agents goes. I will show you in a minute. But we can add Python code, like for example, we can implement tools, MCP servers, whatever you want, but it's not the main logic of the agent interactions. Finally, all of this other stuff like scalability. It's async first by design. It actually checks whether you use async. It's parallel by analysis, so it does the topological sort on every run you do. And it actually supports dynamic graph. So here, an agent is not a static cyclic graph, but rather dynamic acyclic graph. So an agent is like a rollout of nodes. So it first starts with an LLM node. If it wants to run a tool, then it spin ups a new node in a DAG. It recomputes the topological sort, checks whether there's any option for parallelism by automatic. No, I didn't optimize that. It's still O n squared. By the way, if everybody would like to help me with that, I will be happy to. But the graphs are not that big for now, so it doesn't make sense for this. We want to have error handling, we want to have observability, because we want to have policies, because we want to, for example, on that user we shouldn't spend more than $10, right? Please tell me how to implement this in LangChain. This is a toughie. And here you just write a policy, token cost is this times this. If this user has done more and more, you just enforce a policy, and then it just fails every node that they trigger on an agent. Okay? Simple. Then finally, this is the choice that the framework does the heavy lifting. Presumably a lot of bugs here because it does heavy lifting, but that was my choice, that I want a heavy lifting framework. And finally, for me, I know that the clients care only for one thing. It works fastly every time, the dot, period. And this is how it's done. And now let me show you a couple of things how it's built, okay? So I'm gonna go to the architecture so that you know how it's built. So how it's built. All right, so I told you, async first, event-driven, type safe, hexagonal, declarative, DAG-based. This is the 6 principles we took here. First of all, we have the configuration layer. We have a YAML file as an agent file. I show you one. We have a manifest loader similar to Django one. So we load the manifest. How much time do I have? 5 minutes? Okay, I'm gonna go. Then the manifest loads the Python code. Then we have a registry similar to Django again. We have Bootstrap, component storage, schema generation, lifecycle management. There's some caching here. Then we, out of the YAML, we build a pipeline. We obviously have validator, builder of the graph. So we assemble the initial DAG here. Then what is returned from here is a graph plus the config. Config is everything that is not a graph. So for example, which LLMs to be used by which agents, okay? Which agents uses which database. This is config, okay? Then we have orchestration. This is all of the initial work, like port configuration, event system, policy, resource management, all of the, like taking secrets from Key Vault so that they are stored in memory before running the wave-by-wave execution, parallel. Actually, you can, every wave or every node, you can, for example, use either local executor or remote executor. This is where I'm working on now. By the end of the year, I want to have a complete Azure pack, since we are mainly on Azure. And the GCP pack will be next, so that you have a plug-and-play solution that, for example, you have a main node that is a fast API server, and then it deploys dynamically agents on a graph, on Cloud Run or Azure Function. That would be an example of how this can be done. If you have, for example, agents processing images on the runtime, this could be useful for you because a lot of these images will take a lot of your memory. Or, for example, if you work with audio, you might hit that bottleneck. Or a lot of users. And obviously the waves. I know we have execution layer, some policy check, input validation, function execution, output validation, result storage, and event emission. We have 2 event emission. One is the observer one, the other one is control one, so the policy, so that the policy is based on the events that are emitted. So it's node completed, node failed, node started, and then the policies are emitted. There is a lot of integration layer. We use classical ports and adapters. So the ports give us interfaces. So what method should an LLM use? What should be the memory, database, secret, and all of these others can be implemented. Very nice thing is that we can use mock adapters in tests, so it's very testable, very easy to test your core. Oh, and finally, I forgot this observability. And finally, I forgot because we have the registry, and the registry is open. So basically, you can register your own stuff, and the YAML file will actually understand the new types of nodes that you added. For example, you want to use an ETL node. That's actually what we are using this mainly for, merging ETL with LLM processing. You can just build a plugin for that. So it's like an open to modification. If you, for example, want to build a better agent implementation than I did, presumably you can, then you can replace my implementation of your agent, and still you will be happy with everything that I provided, but you will have a better agentic implementation that I did, and presumably you can do this, right? So if you want to do this, you can. I want to do integration with LangChain, actually. I want to do integration with N8N, etc., etc. The happy news is that I'm gonna have signups for private beta of this. So that's the happy news, I hope. I'm gonna give you my GitHub for that. Sorry, the button of sign up for private beta doesn't exist, but you can start the repo, you can watch the repo. I will make some public announcements, I hope, next week. Sorry, I'm traveling a lot. So, that's my studies class on Python, sorry. I have to find, alright, that's the repo. It's called github.com/omniviser/hexDAG. This will be always, oh, you see that I like Pudelek. Yeah. So basically this will be always open source. Actually there's more stars now, I guess. This will be always open source, and this is what we actually have found out with the clients. We want to give it to you now, so that we will have a private beta. You will be stored. Maybe we can talk with Paweł and I will make an official private beta announcement. Then you can join the adventure with me and become a contributor to that. Thank you.
Thanks, Ian. Okay, time for questions. Do we have questions? So actually, can you... Oh, there are some questions at the end. In the meanwhile, can you maybe tell more about becoming contributor here?
Yeah, so basically, guys, you just you can I know. So I'm gonna do the sign up for private beta next week. Okay, I just have to make my marketing guy that helps me with doing all of this community work around that, to set us up the Google Forms for this, or I know we have some Microsoft Forms or whatever, and then you can join. And then you can talk with me, and we will have, you can become a contributor. Right now the code is not public, not because I am hiding something, it's because I feel there's still a lot of stuff that has to be done here, especially checking, performance checking, better documentation and all other stuff. But if you would like to join me, you can just write to me on LinkedIn as well. I will be happy to even now give you access and passes to the code. I actually work on that code. It's me plus 5 interns, so that's kind of an interesting thing. So this is how we do interns in our company, actually, is they join me in this experimental project. So yeah, I told myself I'm head of interns.
Okay, so I have a question. Are you planning to introduce an evaluation functionalities to the framework?
I don't think so. So to be honest, I want to build this as an agent orchestration framework, as a library, not as a fully fledged tool. I was thinking what I want to introduce to the framework, and I want to build this as a library for now. However, because it has plugins, you can work with plugins and you can build one yourself. as an example, I was thinking whether to, for example, give it a fast API deployment. To be honest, for now, I have abandoned these plans because for now I'm the only contributor. So right now, the most important thing for me is to finish what I have and then maybe adding some evaluation thing to this.
Yeah, I can imagine that you mentioned the dynamic nature of the graphs, and it may be quite a challenge to evaluate such solutions.
Yeah, but on the other hand, you have a clear context when you have a dynamic graph. So you have this was the context at that evolution of the graph, then this context, and you know that each node is basically like a state machine. So it has a state, and then it passes a state to the next node. So it's kind of a natural how to debug this kind of stuff. You just look what is the context at that point of the graph. While in lang graph, I can tell you, I don't know how this node, what is this node state? I don't even know whether this is a well-defined concept. I don't think it is, if you think about it, because the nodes are cyclic. And the graph is not, it's just representing how the agents interact rather than the actual interactions.
Thank you.
Obviously, without LangChain and without LangGraph, that would be impossible. So, you know, as much as for every first runners. Yes.
Right.
What is your LLM abstraction layer like? You said you want to make it easy to swap LLMs. So
all right.
Basically, there are many libraries for this. But
yeah,
you can also write your own.
I have a roadmap. I want to use Light LLM for now. But the LLM abstraction layer in the code for now is core. I guess it's core ports. This is a very simple one, and presumably it has a port, a namespace, and the namespace isn't important. It just has to have any LLM will do as long as it has a response with tools, and basically health check, and that's it. Everything that satisfies this is an LLM by the properties of this framework. For example, the mock LLM is just a list answering parts by parts, and it works pretty smooth. However, I want to give batteries included, so I want to give integration with Light LLM. I want to definitely do Azure, OpenAI. I want to do GCP for sure. Yeah, this is what I want to provide by the book. I hope that answers your question.
All right, there's one more question.
Hi, thanks for the talk. I got a question. Such frameworks are awesome, but when we're working with such systems in practice, the first thing that comes to mind is logging and how you can see what's going on inside. I think LangChain's biggest advantage is the integration with Langsmith or the existence of LangFuse. And I wanted to ask you, how does it compare to your framework?
The orchestrator just emits event when a node is started, when a node is finished, etc., etc. There's also some special type of events like a prompt, what the prompt was sent, what is the response, etc. And then what you do with the events. Well, you have a port for control as well as observability. You can then implement yourself whatever you need. So if you want the Kafka one or you want any other, then you can do this. I support some basic ports. However, to be honest, one of the biggest things to do right now with the framework is to give a reasonable outside of Omniviser user experience of the framework. So I want to do that as well, to have some logging and monitoring. However, yeah, with LangChain I always have troubles.
Okay, thank you, Janek. Yes, let's thank our speaker.
Hey, if I may, 1 minute. So may I ask a question to you? Can I make a selfie with you guys?
Okay.
Okay. So you say LangChain. All right. I'm gonna try to that way. Okay. Yeah. So now we say lang. Okay. Let's make a video. All right. So now 3, 2, 1. We say. And now again we say hexDAG, right? Okay. So 3, 2, 1. Thank you, guys. All right.
All right. Thank you. Thanks, Jan.
All right.
Okay, that was the last talk for today. So it's time for after party. The food is already here, so enjoy. Thank you.